Today's daily code problem of the day is smallest subarrays with maximum bitwise OR, number 2411. For this problem, we're given a zero-indexed integer array called nums of length n, consisting of non-negative integers. So for each index I from 0 to n minus 1, we must determine the size of the minimum sized non-empty subarray of nums starting at I inclusively that will have the maximum possible bitwise OR from that position. So in other words, we need to calculate the maximum possible bitwise OR from each position. To do this, we are going to keep track of the last time we saw each bit. So, for example, if we're looking at something like 3, a bitwise representation of 3 would be 0, 1, 1. So that has index 0 and index 1 bits that we would want to keep track of. We can kind of look at it like this. So if we have 3, its bitwise representation is going to be 0, 1, 1. We are going to keep track of this by identifying each of these having an index. So this is going to be index 2, this is going to be index 1, this is going to be index 0, and we're going to keep track of this in a vector. And each time we need to get this bit, for example, we're going to store the last known occurrence at index 0, and we are able to call for this index to add it to our subarray and collect that bit and use it to get our maximum possible bitwise OR. So let's go ahead and jump into the solution. First thing we're going to do is let n equal our nums.length. This does not need to change, so it's not mutable. And then we're also going to identify a mutable vector called our last scene. This is how we're going to keep track of the last time we saw each bit. So it's going to be a vector from 0 to 30. And the reason we're using 0 to 30 is because if we look down here, possible numbers go up to 10 to the 9th, which means 31 bits. Also, we can see up here the vector is 32 bits. So we know that we're going to use a possible total of about 31 bits. And so we're going to use from 0 to 30 as our bits representation. Again, we're going to mark these as the last index that we saw them. Then we're also going to identify a mutable result vector. So this vector is going to be from 1 to n, and that's simply because it's the shortest possible subarray is 1, and then the longest possible subarray is n. Then we're going to jump into our for loop. So the first thing we're going to do is reverse our array. So we're going to travel backwards through our array, and this is because our vector, if you think about it, this vector is kind of going to be backwards. So typically the bitwise representation is the biggest number is in front, and then the smallest number is on the back. So this number is much bigger. This number is much bigger than this number, for example. So in our last scene array, we want to kind of reverse it to ensure that we are tracking the bits accordingly. So for each I in from 0 to n, we are going to dot reverse. Then we are also going to do a for loop for each bit in our bits from 0 to 30. We are going to use a bit mask to identify if the current index we're looking at has the bit we're looking for. So if our nums of I, and we're going to use a bitwise AND operation and apply it to our bit mask. So we're going to set the value of 1 to the position of bit. And as long as this is greater than 0, we're able to update our last scene for this bit to be equal to I. So what exactly is going on here? We're using a bit mask to identify the last time that we saw this bit. So for example, nums of I, this could be the number 2. So 0, 1, 0 for the number 2. And we want to find this bit and this bit. So we come across the number 1, or the current bit is going to be, let's say, 0, because we're looking for this 0 bit. So nums of I, the current number we're looking at, let's say the current number we're looking at is 1, and we're going to use a bit mask to identify that we want this bit. So we're going to shift over the value of 1 0 times in this occurrence because we're looking for the 0 bit. So we're going to have a 1 here, and we're going to AND these together. So the bitwise representation of 1 is 0, 1. Bitwise representation here is 0, 1 as well. So 0, 1 and 0, 1, it's going to end up being 0, 1. Remember, a bitwise AND operation, 0 or 1 is going to be 0. 1 or 1, it's going to be 1. That is our bitwise AND operation to use a bit mask to identify if we're looking at a value with the correct bit that we're looking for. After that, all we have to do is simply update our results. So result of I is going to be equal to the result of I dot max with the last being bit minus I minus 1 or plus 1, this is 0 index, and as an integer 32. So we're going to update the result as needed using this last seen bit if it increases our or not. And then we can simply return our result. So if we run this, passes our test cases, and if we submit it, passes all solutions. So thank you, and follow for more daily LeetCode solutions.